Hi, in today's lesson we're going to be looking at calculating the standard deviation. So we're going to have a quick recap of what we've done so far. So what we've been working on is averages, the mean, the median, the mode. There are three different ways of calculating an average. We've also looked at finding the quartiles. So the median is obviously the middle value, or if there's two, we add them together in half. And we've also found the lower quartile and the upper quartile. So the range formulae that we have worked with so far, the most basic one being that we do the highest value in the list, subtract the lowest value in the list. Slightly harder at the interquartile range, where you have to do your upper quartile, take away your lower quartile. And your semi-interquartile range, remember that a semicircle is half a circle, so your semi-interquartile range is half your interquartile range. Now the interquartile range and the semi-interquartile range, they go with the median. Whilst we work out the median, we work out our quartiles as well, and that gives us our interquartile range and our semi-interquartile range. So here's the standard deviation formulae. You get these two formulae on your formula sheet. This one works well on the non-calculator paper as well as the calculator paper, and this one, I would save that one just for the calculator paper there. Okay, so we have got a new symbol here, sigma. That just means add, find the sum of. N is the number of data values. How many numbers are in your list? X is each of the numbers that's in your list, and X with a bar is a new way of writing the mean. So we can now write the mean, X bar is equal to the sum of the X's divided by the amount of numbers. Don't get scared by it, because we will work on this together and it will make sense. Now our standard deviation is another way of looking at how spread out the values are. Okay, so our range formulas are about how spread out our values are, and so is the standard deviation. Now the standard deviation goes along with the mean, okay, whereas these ones up here went with the median, these ones go with the mean. Okay, so when the standard deviation is low, the data values are close to the mean, and when the standard deviation is high, the data values are spread out from the mean. So when we compare data sets, it's important that we consider two things, that we consider the average for the data and the spread of the data as well. So we know that we've got our three ways of measuring our average. And when we're comparing averages, we don't use the word mean, median or mode in our sentence. We start our sentence with on average. So let's have a look at an example. In a survey, the mean temperature in Fraserburgh is 8 degrees and in Aberdeen it is 10 degrees. So we could say for these two means, okay, on average, the temperature in Aberdeen is higher than Fraserburgh because the mean temperature is higher. 10 degrees C is larger than 8 degrees C. Okay, but notice that we must have this on average bit here. But we must also consider the spread of the data as well. So again, we need to start the comparison sentence with the context that we're working in. The smaller the spread means the data are more consistent, they're more tightly packed together, they're more consistent or they vary less. And then the larger the spread means they're less consistent, or actually they're varying more because they're more spread out. So sticking with Fraserburgh and Aberdeen, for temperatures, the standard deviation in Fraserburgh is 5 degrees C and in Aberdeen it is 9 degrees C. So what does that mean? The standard deviation is a measure of spread. Okay, so here's our sentence. The temperatures in Fraserburgh are less varied than the temperatures in Aberdeen because the standard deviation is lower. 5 degrees C is less than 9 degrees C. Now we can also say the temperatures in Fraserburgh are more consistent than the temperatures in Aberdeen because the standard deviation is lower. Or the temperatures in Fraserburgh are less spread out than the temperatures in Aberdeen because the standard deviation is lower. So different ways that you can say the same thing there. Okay, so here we have our first question where we're being asked to calculate the standard deviation. So we have our 5 values at the top here, and we've got this lovely formula which we're not going to panic about. Okay, so I've started to set up a table here. I'm going to show you what goes into this table. We are going to put in our data values. Pick a colour. Here we go. X. In the next column, I'm going to take the top part of the fraction. And in the last column, I'll add on the squaring part. Now, what do I need for this? Oh, I need to know what x bar is. Now remember, that is our mean. Okay, so we can't work anything out in our table until we've got our mean. So remember, that means to add the values together and then divide by how many values there are, which is 5 in this case. Okay, and that comes together to make 37, and then 37 shared by 5 is 6.4. Okay. Next job, I need to take each of my data values from up here, and I need to put them into my table under the x. Okay, so my data values were 12, 5, 3, 8 and 9, so that's those in place. So next column, I have to take my x and I have to subtract the mean. Okay, so I've just taken my x values across to the next column, and for each of them I'm going to take away the mean. Now the mean is always 6.4, and I'll be using a calculator for this one. Okay, so the first one comes out as 5.6. which needs to be squared. Okay, next one comes out as minus 1.4. Remember, a minus times a minus makes a positive. Now that's where it becomes important that you put your bracket around your negative number there. Okay, just going to carry on filling in this table. So the last column should end up looking a little something like this. So going back up to my formula, I have my addition symbol here. I have to add together all my x minus x bar squareds. Okay, so that means that I'm going to add all of these numbers here up together. So I've just worked those out in my calculator, and I've got 54.2. So that is the sum of my x minus x bar squareds. So I've just worked out the top part of that fraction. Okay, next thing I'm going to do, I'm just going to write down the formula that's there. Okay, so I've just copied that formula. Remember, it will be on your formula sheet. So it starts with a big square root over the top of everything. I have the answer for the top. It comes from here. The answer for the top is 54.2. Now the bottom, n minus 1. How many values were there? If I go back to my original list, there were 5 values. 5 take away 1 gives us 4. All I need to do now is to put all of that into my calculator. So hit the square root button, hit your fraction button, put that on the top and that on the bottom and press equals. Okay, so I've got that typed in. Pause if you need to do it yourself. I'm going to do 2 decimal places, so I'm writing down 3 from the calculator, and then think to yourself, do a round up or down for a 1? Down for the 1, so we get 3.68. Okay, this question here, some of the work has already been done for us, so I'm going to start by writing down my standard deviation formula. Okay, again, remember you get that on your formula sheet. Now, they've told me the bit for the top of the fraction is 42. And they've told me that there were 5 pieces of data, so for the bottom, 5 take away 1 makes 4. So I'm going to put this working out into my calculator, and it gives me 3.240. Again, I'm going to round it to 2 decimal places, which gives me 3.24. Because I've rounded down for the 0. Okay, in this question here, we are being asked to find the mean and the standard deviation for 5 scones. So I'll start by calculating the mean, where I need to add all 5 numbers together and then divide by 5. And this works out at 150.6, and I used a calculator. So I'm starting to think about what needs to go into my table now so I can calculate my standard deviation. So remember, the first column is our values, which we call x. And our values, of course, are the 152, the 145, etc. So that's my 5 values in my table. Okay, so I'm going to write down that formula, which is on the formula sheet, remember? And remember that the middle part of my table will have the top part of that fraction there. Okay, x minus x bar in the middle column, x minus x bar squared in the final column. So I'm going to start filling in my middle column now. All I've done there is transfer the numbers from the first column into there. And what is it I've got to take away? X bar. X bar is my mean of 150.6. So you should see that I finished off this column here by writing take away 150.6 for each of my values. I'm going to start putting those into a calculator now. And when I do that, I'll also need to square them. So I've done my subtractions there, and that's me ready to start squaring each of those values. And that's what the third column ends up looking like. Okay, so next thing that I need to think about is finishing off this top part, remembering that that symbol there means to add, so that means we've got to add all those values together in that last column. Okay, so I've popped in the top part of that fraction from the formula, and I'm going to add these 5 numbers together now. Okay, and that's come to 53.2. So I can start to work with my formula on the left hand side now, because I know the answer to the top is 53.2. The value for n take away 1. How many values were there? It was 5 scones that we were working with. 5 take away 1 gives us 4. So remember, let's get this in our calculator, press the square root, press the fraction button, 53.2 in the top and 4 on the bottom. Lovely long decimal again. So that's coming out as 3.646. And I'm going to round that to 2 decimal places, 3.6. Do a round up or down for that 6 there, up. So the 3.64 becomes 3.65. So I've done as I was asked. I have got my mean which is up here. And I've also got my standard deviation of 3.65. Remember, this is an average. Remember, this is how spread out the weight of the scones is. So, part B. On a second production line, a sample of 8 scones this time gives a mean of 149. How does that mean compared to that one? So that one's slightly smaller. And a standard deviation of 6.1. How does that compare to that one there? So that one's larger, so these scones' weights are more spread out here than they were on the first production line. Okay, so I'm starting to think about getting this down in writing. So when I compare the two means, I need to start by saying on average. So what I've got here is, on average, the scones on the second line weigh less. They weigh less than the scones on the first line. So that's me compared the means. Now I need to compare the standard deviations. Remember, I like to talk about spread for these. So this is where I've noticed that the second number line, the weights are more spread out than they are on the first number line. So when I'm comparing the standard deviations, notice there's no mention of standard deviation in my sentence here. I've written also, the weights of the scones on the second line are more spread out than those on the first line. So there's an example of how we compare the mean and the standard deviation, noticing that this sentence here uses the word average, not the word mean. And here I'm talking about how spread out they are instead of using the word standard deviation. Okay, so that is you now ready to work on these questions here from your TJ National 5 textbook.